Hello, this is Professor Welch. I'm recording a summary of the Teams meeting that we held earlier today, Thursday, September 17th, in case you were unable to join us for the meeting or in case you'd like to review the points that we went over. During the meeting today, I gave a brief overview of some of the key points of the design of the data mining course. We also talked about the project that you completed last week. We reviewed the summary sheet that I provided to you for that project. And we also talked about the project that you're currently working on. So for the first point, I wanted you to understand the rationale behind this course and its design. I spent a lot of time over the summer working with an instructional design consultant, and we very carefully thought about the learning objectives that we wanted you as students to accomplish in this course. And the learning objectives are based on real world skills that a data miner would actually use. And I'm a data miner. I work in the field of bioinformatics and I mine genomic data. And so the skills that I'm teaching you are skills that would be valuable in my lab or in any other context where data mining is done. I also put a lot of thought into how would I assess your skills as data miners and what activities would you do in order to learn the data mining skills that I'm teaching you. And I decided to use a real research project that I'm currently working on with a scientist at the National Institutes of Health. We're studying cancer genomes and we're trying to discover genetic mutations that relate to cancer and that could potentially be used as diagnostics and also to help to gain insight into how the cancer actually works, how it operates. So I've gotten permission, special permission, to use one of the data sets from our research study. So you get an opportunity to actually analyze data that no one else in the world is currently analyzing. And it's cutting edge data. And I think that's really cool. And I hope you enjoy it as well. So the project that you completed last week, I provided a summary sheet for you at the beginning of this week through email. If you didn't get that, please let me know and I'll resend it to you. I have heard from a number of students that you have received it and that it was helpful, so I'm glad to hear that. The reason I prepared the summary sheet was just because I felt a little concerned that about a third of the students didn't seem to fully understand some of the foundational concepts that we're going to be building on as we move forward. Mainly the concepts of true positives, false positives, true negatives, and false negatives. These form the basis of a lot of the analysis that we're going to be doing in the coming weeks and throughout the remainder of the course. So one way that I think it might be helpful to think about these is think about a COVID test, a COVID-19 test. If you took a COVID-19 test and you got a positive result, but it turns out you didn't actually have COVID, that would be a false positive. The test got a false result that you were testing positive for COVID. If, however, you actually have COVID-19, I hope you don't, but if you do and you got a positive test result, that would be a true positive. The result of the test is true and the result is positive. Our governor actually recently, within the last month or so, did take a COVID-19 test and he tested positive. But it turned out that he was retested a couple more times over the next couple of days and he got negative results. And it turns out he actually did not have COVID-19 and yet he tested positive. So his first positive test was a false positive. The following test that he received, which showed a negative result, that he did not have COVID-19, those, it turns out, were true negatives. They said that the result was negative, and that was actually the reality. That was the true result. Similarly, A false negative would occur if someone took a COVID-19 test, the test came back negative, but the person actually has COVID-19. So I hope you understand these concepts. I hope the handout was helpful. Please, if you have any questions about these concepts or anything else in the course, always feel free to send me an email. And I try to respond very quickly to email that I receive from students in this course. And finally, we talked about the current project that you're working on. What we concluded from last week's project is that there's no perfect genetic test based on a single genetic mutation that could have 100% accuracy. So what we're beginning to do this week is to look at building a framework where we can develop a multiple genetic mutation test. So using more than one genetic mutation to come up with hopefully a very highly accurate test. So we're going to begin with doing stage 1 of the project this week. Next week will be stage 2. I've broken this down into 2 parts because I felt that it would be a little bit too much to do within 1 week. Next week's component will be more than this week. So this week's might seem a little easy. And if it does, that's great. That means that you're up to speed on things. Next week's will be a little bit more work. So this week, what we're going to do is we're going to figure out what's the best genetic mutation for testing for cancer, given the data set that we have. Then we're going to take that genetic mutation and use it to divide our samples into 2 groups. The group of samples that have the mutation and the group of samples that do not have the mutation, group A and group B. And that's pretty much it. I need you to pick the best mutation, tell me what are actually the top 10 mutations in terms of being able to diagnose accurately. And then for the top mutation, tell me which specific samples contain that mutation and which specific samples do not contain that mutation. And we're going to build on that next week. What we're going to do is apply this process iteratively. We're going to take group A and group B, and we're going to repeat this process. For group A, and again, I'm talking about next week's work, so just want to give you a sort of a preview of where we're heading. Now, so next week, we're going to take group A, and we're going to find the best mutation that further subdivides group A, the group A samples. And then we'll find the best mutation that best subdivides group B, the set of group B samples. So I hope this is helpful to you. And as always, please feel free to reach out to me, welch@ohio.edu, if you have any questions. I hope you have a good day.